Example 8, we're going to look at what happens when we have a phase change in a material. And we're told that we have some soda, we're putting some ice on it. What happens to the final temperature when all the ice has melted? So if we look at the energy associated with the soda, that's going to be the mass of soda, specific heat of soda, which we're told is mostly water, times the change in temperature for soda, and then the energy associated with the ice is going to be the mass of the ice, specific heat of ice, times the change in temperature for ice. But we have to add to that something called the energy for the phase change, which is the mass of the ice times something called the latent heat of fusion for ice. And this is for melting. We're told that we have no heat loss, or we can ignore it. So that means that the energy for the ice has to equal the negative energy associated with the soda. And if we plug this in, we get mass of ice, C of ice, T final for ice, minus ice is normally at 0 degrees Celsius, plus the mass of the ice. I know it sounds like mice, but it's mass of ice, latent heat of fusion for ice, and that's going to equal minus the mass of the soda, specific heat for soda, times final temperature for soda, minus the initial temperature for soda. When all ice melts, that means we are at thermal equilibrium. Which means that T final for the ice has to equal T final for the soda. And if we use that, we can get that T final by itself is the mass of the soda times the specific heat for soda times 20 degrees Celsius minus the mass of the ice times the latent heat of fusion for ice over the mass of the soda plus the mass of the water times the specific heat of water, keeping in mind that the specific heat of soda is the same as the specific heat of water. So now we can plug in what we know, 0.25 for the soda. Specific heat for water is 86 joules per kilogram degrees Celsius times 20 degrees Celsius minus, we have 3 cubes each at 6 grams, so 0.006 kilogram. That's the mass of the 3 cubes of ice. The latent heat of fusion for ice is 334 times 10 to the third joules per kilogram, all over 0.25 kilogram plus the 3 times 0.006 kilogram, that's the mass of the water and the soda, times the specific heat of water, which is 4186 joules per kilogram degrees Celsius. gives us a 13.3 degrees Celsius.